All right, this is H coming at you with another tutorial video on Autodesk Inventor 2023. We're going to be finally getting started with the filter plate 2-8, the part file that was kind of previewed and hinted at earlier on in this video series. And it's going to be right here. I'm going to pull this over here. I'm going to be using this as part as a document to emulate and to create this filter plate 2-8. Following along with this drawing, I'm going to create this part. So let's first talk about the drawing itself. As we look at the drawing itself, it gives us our three views. We have our front view, our top view, and our isometric view here in the corner. So we have a lot of numerical dimensional information in this front view, not much in the top, and absolutely none in the isometric view, as the dimensional information is not normally given in an isometric view on a part drawing. So this is the part we're going to be doing. And the first step that I always tell students as far as where to begin when making a part file, especially in a replication process that we're currently working on now, we're going to make this part. We always start by looking at our views and determining which view should we start with our sketch that gives us the most information. And there are two types of information that we look for. We look, number one, for the numerical dimensional information, numbers. Numbers are what matter, the dimensions matter. And so we look for that and what gives us the most information that way. It's very plainly obvious, as this is the first part we're looking at. We wanted to make it obvious. It is this front view. This front view has the most numerical data on it. It has the most information on it. In that sense, for the dimensions, this is perfect view to start with. The other type of information that is important to look at and start with is visual information. Visual information is curvature of lines, circles, unique features like this diagonal could be a visual kind of informative piece of information. And it's information that is visually acute rather than numerically or dimensionally acute. And so when we look at the circles or any kind of curves or a slanted line, that type of visual information is important to look at and to see on a drawing, and see what view provides the most visual information as well, looking at specifically circles, curves, as those features are harder to replicate or take more steps to replicate at the end of the process of making this part, rather than in the beginning. If we make them in the beginning, it'll be quicker. And that's what it's about. It's by making this part as efficiently and as quickly as we can with the fewest number of steps and headache to get there, right? So this is where we're going to start. We're going to start with this front view of this part. And we're going to create this part. So we have our front view, we have our top that shows us how thick the material is, and of course we have our isometric view right here. So I'm going to drag this over to the side, so I'll be referencing that and looking at that as we go. But I went back into like the home screen, the clear screen, as far as where to begin. And the first thing we want to do is we want to go to new. Right, we want to go to our window here, our page with a little dog ear on it, and go to the English standard IPT. This is an inches part. The filter plate 2-8 uses the inches measurement system. So I want to go to create, or I can double click on it, and it opens up a brand new part file. We have part 3 as the current name, right? And we're looking good. Now, if we reference the drawing, we were using the front view of this drawing of this part to create this. So we're going to go to start 2D sketch, always where we start. And we're going to go to the XY plane. The XY plane has the X-axis, Y-axis in it, and our 0, 0 mark here, this is our origin, where X is 0, Y is 0. We like to start drawings at this point to give Inventor a reference of where you are locating your object inside the three-dimensional space. It's a reference point. It's a point that's going to say, okay, our part file is going to be here. And so we want to start with that location as well. Now, it's kind of off in the center of this, and we're going to be drawing most of this part file in this first quadrant here, where there's positive numbers in the X value, Y value. So in order to get a better view of this, I'm going to come over here to this little this little tool here, the pan, right? And I'm going to click it and just kind of click and drag, holding down over, getting a better view of this. And again, I can right click and click OK. The right clicking of the mouse does a lot of different stuff on it, which we'll talk about in another video. And so we got our origin point now down here. And so it gives us more visual space here. And we're going to need that visual space in order to do our sketch. So the first thing we're going to do is we're going to go to the line tool. I'm going to start here at 0, 0, X is 0, Y 0. Here it is. I'm going to click that in. Now notice this green dot appears. This green dot will always appear when you are creating an entity like a line, a circle, or a rectangle, or something. You're making something on a pre-existing location. And in this instance, it's the origin. In other instances, it might be another line that you've made or just something else that's made and in the sketch already. So we'll click there and we will expand up. As we expand up, we need to know the length of this line. And if we reference the sketch that we were going off of, oh, let me do that. There we go. We have this. We know that this line here is 2.5 inches, right? So we can type that in. That highlighted text box is the length of our line that we talked about in the line tool video. And we have a 90-degree angle. And that's important because this line is a vertical. Now notice there is a symbol. I can't really mouse over to it, but there is a symbol here. Actually, I can. Here it is right here. This symbol here is the vertical constraint symbol. And you can see the same thing over here. Vertical constraint. It causes a line or something to be parallel to the y-axis. So when this appears, we know we are parallel to the y-axis. And in this case, we are on the y-axis. And that's good. That is a vertical line. So I can hit enter on the keyboard. And my line goes way out of screen. So I need to, again, adjust my visual frame of reference here. And the easiest way to do this at this point, I'm still in the line tool. I haven't exited. I haven't hit the escape key. I've just made one line and hit enter. And it's Inventor is saying, oh, you want to make more lines. So they're keeping the tool open. You can see it highlighted here in the ribbon. And we can see that we're still in sketch mode with the green checkbox. And we can see right here, we're bringing a line down that comes off screen somewhere, and it's coming down towards our screen here and has a length of 2.612. And what we need to do is we need to go over to the view cube here and just click on the word front. I'm just going to click it. And again, it's going to expand it out a little bit. It's going to zoom out a little bit. And we can adjust this again by going to like the hand tool and kind of pulling it over again. We can also use the mouse wheel to do that, to get a good adjustment. Zooming in and out with the mouse wheel is important. We can right click and click OK when that's done. And again, we'd be back right into the line tool after using the hand tool, the pan tool, to kind of adjust our positioning, right? So now we have this line that's going to be going across here, which is 2. So we have a 2-inch line, again, a 90-degree angle that is measured off of the existing line that we already have. And in this case, the symbol that is appearing here is perpendicular, which is this constraint here. And this is also another important constraint. It is a constraint, a relationship, a rule between the two lines that we are drawing, that they will stay perpendicular. They will stay at right angles, 90 degrees from each other in the geometry. So that symbol appearing there is a good sign, because these two lines now will have 90-degree angle. They're going to be perpendicular. They're going to stay that way. The rules will be set. So if I can hit enter again, and I have that now 2-inch line, you can see the perpendicular relation there, just kind of showing me like these lines are perpendicular, they're right angle at this location. Now this diagonal line here, this is an interesting situation here. This line here, as I'm going to go ahead and click OK and kind of be done with that, because I'm not going to draw this line yet, because if we look at this, this is our drawing where we're going off of our little drawing. We drew this vertical line up. We drew this horizontal line over, and now there's this diagonal line coming down this way. We have no information regarding this line as far as its length or its angle, but we can triangulate its position based upon what we know about the 3D coordinate, the coordinate system, right? We can either draw this in to this point, like come back down to the bottom and draw it in, Or we can do a little bit of math. Math is easy in this case, and get this location here and get the length of these two sides that aren't really here, but this would be the hypotenuse of a triangle, right? And so that's what we could do. So I'm going to actually do, I'm going to do a little bit of the easy way this time around, just for the sake of learning. And we're going to go back down to 0, 0, and we're going to draw the bottom of this and come back up, and you'll see what happens. All right, so we go to the line tool, we go to the 0, 0 origin, we click our origin point again, we're going to 0.5, that's our length of our line again, we're going up vertically 0.5. Again, I'm double checking to make sure the perpendicular is there, the horizontal is there, and it is, so I can keep moving forward. Now this line here, this is going to be another 2.5 perpendicular line. Then we have a line, another 0.5 coming down, this little foot piece that's going to be here, another 0.5 going over horizontally. And then we have this line here. This is the last line we have as dimension for, the last kind of component that we're looking at. This is a line vertically 1.5. And now we can see, we can just drag this over here and click on this green dot. And that line is exactly where it needs to be. We have the outside perimeter of this part file. You can see we are fully constrained. We have all the dimensions that are needed. Sometimes I like to pull these dimensions outwards like this, so they're not inside of the perimeter of the part file of the sketch here. So notice we always like to do the outside of the part perimeter first. Right? We do that first, we establish those boundaries, and then we work on anything that's on the interior of the part file, right? So the interior of this part file has a couple of circles. So we'll go to our circle tool, and we need to have these circles with a diameter of 0.5. We're going to make one here, and then there's going to be like one over here somewhere. And I just drew those in there. Now, if you watched our circle video, you know that a circle needs 3 dimensions in order to be locked in place, in order to be a fully constrained sketch. All the rules in place that the sketches are going to follow, because these circles can move, right? These circles are still moving. You can see a bit of a color difference, right? We have like a blue line and these are black circles. Normally that color difference when we're sketching determines what is fully defined and what or fully constrained and what still needs to be constrained with dimensions or constraining tools, right? So we need 3 dimensions for each circle. We need the diameter of the circle. We also need its X placement value and its Y value, where it is on this coordinate plane, where it is in this area. So we'll go back to our dimension tool. Our dimension tool, again, it places any dimension, and we can either click on a line that's already been drawn, or we can click on a circle and then another line dimensioning between the 2 entities, right? So we could control the size of a part. We can express this in numerical constraints. We can put equations in here, all these different things. So we can select the circle and select this line here. And this is going to give us our X value of how far away the circle is from the edge of a part, which is 1 inch. Now we need our Y value. So again, we need to click on the circle itself, come down to the bottom here, and we can click that, and then click over here to create the dimension with our mouse. And then we can change the dimensional value, the number, to what we need it to be, in this case, 1.5. So this circle, as you can see, I'm going to click OK to kind of clear out of the dimension tool, is now the same color as the outside perimeter. This is a fully constrained sketch. We did 2 dimensions. We did the X value and Y value. And you can see down here, it took those 2 dimensions away. We were at 4, now we're at 2 again. So we need to do the X value and Y value of this circle, so that way we can get it in the right location. So we'll dimension this again. We'll go to the circle tool. We'll click on the circle, click on the bottom line again. And this is going to be the same. This is going to be the 1.5 that we did before with the Y value for the other one, right? And the value that we're given, we're going to, for the X, is going to be from this line. So we'll click on this line and go to this second circle. This value here, we're given in our drawing 2.25, and we'll hit enter. And then I'll right click and click OK, just to kind of clear out the tool. Instead of hitting escape, you can right click and click OK, and it will leave the tool. We can see now we are fully constrained. We have everything we need. we drew the front view of this drawing. We did the outside perimeter first. That's a good strategy to use. And then we did the interior components, the circles in this case, making sure that we have their diameter dimension and then their X value placement and their Y value placement to get their location correct in the part file and in the three-dimensional space that is here. So as I pull this back over here, you can see we have exactly what it says here. We had all these dimensional lines that were here. This symbol here was diameter of this 0.5. So we have the diameter of the circle there. And so we drew this outside in. So now we got to look at, well, we got to make this 3D. This is a 3D part. So that's what this number here comes into play. The next step, and in this case, our final step for this particular part file to make it 3D is to extrude it. So that's going to be what we do next. Right? So this is done. We can finish the sketch. We're going to hit the green check box. It kind of does this weird zoom out thing. You can hit the home key there that's just above the view cube, or you could hit the corner of the cube itself. Either way, you get a nice kind of isometric view of this sketch. Now, this sketch does not have any dimension on the z-axis. Notice the z-axis is here in blue. It's a flat sketch. It's like a piece of paper, right? If I turn it to the side, on the right side, it's just a bunch of lines, right? There's nothing there. And so we need to add the material. And so this is where we go to the 3D model tab. We left the sketch tab and now put us in the 3D model tab. We are creating material. The simplest way to create material is the extrude tool. The extrude tool creates a feature or body by adding depth to a profile. Now, a profile is, according to definition in the Inventor software, a profile is any closed-in shape, any shape. So sketches like the one we have here have multiple profiles, right? The circle here is a profile. It is a closed-in shape. This circle is a profile. It is a closed-in shape. This whole outside perimeter is a profile. It is a closed-in shape. So the extrude tool works with profiles that are closed in shapes. Now, in the toolbox here, it also says open profiles create surfaces. So whenever you want to make something solid, you make sure you're using a closed in profile, a closed in shape. If you're making surfaces, which we'll get into in a much later tutorial, we can use open profiles where things aren't connected and cleanly done and kind of open. So if I click the extrude tool, this little window here opens up the properties of extrusion. Right now, we are in surface mode is off, so we should be able to, we have our selection. So the highlighted area is the profile that it is currently trying to select. You can see the smallest little blue line right here. We are currently, it automatically put us into that selection box. So we're trying to select a profile. You can see this is a profile, or if I zoom in with the mouse wheel a little bit, this is a closed-in shape. This is a profile. So is this circle, just like we were talking about. So the profile that we're trying to select is this one here. And as you can see, as soon as we select that, the profile here, one profile gets selected. We clicked on that. And the input geometry is from the sketch plane. So from the plane we drew that sketch on, it is extruding, it is adding material, it is adding depth to this sketch in this shape, leaving out the holes. These circles we did not select. Now, if we did, it would fill that in. And we don't want that. We want that to be just an open hole area and no material there. So we're not selecting the circles. So we can also change and manipulate direction here, right? So we'll talk more about this as we get more into extruding, but the default direction is what we're looking at right here. And it's going 1 inch currently in that direction. So here's where that dimension from our drawing comes in. The dimension we are given is 0.13. That is our dimension. That is the thickness of this filter plate 2-8. So we just want to double check to make sure we got everything correct. We got the right profile. We have the from location is from the sketch. Our direction is good. Our distance is good. The output is a solid, right? It is a solid 3D block of material. And we're not doing any taper right now, and actually can kind of ignore those properties a bit. Tapering, we'll get into in a later video. So once we have this extruded and the right dimension we want it to go, the right distance, we can click OK. And that is the filter plate 2-8, right? So in checking your work and checking to make sure your part file is correct, you always want to verify the eye properties. So this will be the last thing we do in this tutorial 4 video that was all about filter plate 2-8. We're going to go to the part file. And again, you could save it right here, save as filter plate 2-8, be absolutely good to do. But if we right click on the part name in the browser window, we can go to the eye properties and we can go to the physical tab, update this because right now we have no mass, we have no area, we have no numerical information regarding our part file. So if I hit update, Inventor will now calculate all those values about this specific part and this specific part in the material that is known as generic, right? Generic material is typically a plastic style of material, but we could change this to any one of these listed materials here in Inventor, and that would change our mass values as well as some other values that are in here depending upon what we change it to. So right now our mass in generic material is 0.030 pound mass. Remember, this is an imperial inches location object using the IPS measurement system. That's inches, pounds, and seconds, right? So this pound mass here, if you follow along and did this part, this is the pound mass that you should be at and located. And if you have this, you are 100% correct in your creation of the filter plate 2-8. Thank you for watching. We'll see you next time.